Now we're going to look at another important trigonometric function and its limit. So if you have the limit as theta is going to 0 of 1 minus cosine theta all over theta, and this is equal to 0. So we want to show that this is true. So notice again, if we did direct substitution, which is really where you should always start, you'll be surprised a lot of times it does work. Plugging in 0 wherever we see theta, we'd have 1 minus cosine of 0 all over 0, but cosine of 0 is 1, so we have 1 minus 1 all over 0, or 0 over 0. So indeterminate form, again, it doesn't tell us anything, so we got to try to manipulate this. So let's try by multiplying through by the conjugate of 1 minus cosine theta. And we're going to multiply by a fancy one, so we can do this. So I have 1 minus cosine theta in the numerator all over theta. And I'm going to multiply this by 1, and it's going to be the conjugate of our numerator. So 1 plus cosine theta all over 1 plus cosine theta. So notice that's a difference of squares in the numerator. So that's the same thing as a squared minus b squared if we distribute that out. And so doing that, we have the limit as theta is going to 0. Well, foiling this out, we got 1 quantity squared is 1 minus cosine theta times cosine theta, cosine squared theta, all over, I'm not going to distribute the bottom, theta all times 1 plus cosine theta. So you should recognize what 1 minus cosine squared theta is. So recall the Pythagorean identity, cosine squared theta plus sine squared theta was 1. So by the Pythagorean identity, this is the same thing as sine squared theta. So let's rewrite that. So we can rewrite this as the limit as theta is going to 0 of sine squared theta all over theta times 1 plus cosine theta. Well, now that we just proved that the limit as theta goes to 0 of sine theta over theta is 1, let's manipulate this so that we have that in there. And so let's rewrite this. Sine squared theta is the same thing as sine theta times sine theta. So I have sine theta all times sine theta. And notice I can split this up as 2 separate fractions that I'm multiplying together. And so I can think of it as the first factor in the denominator, theta, and then all times the second piece in the denominator, sine theta over 1 plus cosine theta. So now using our limit rules, remember we could take the limit of the first function times the limit of the second function. And so let's go in now and do direct substitution or use what we just proved. So that first piece we just showed was 1. So this here, by that theorem, was 1 times, so let's go in and again do direct substitution. So this time when I go in here and I plug in 0 wherever I see a theta, I would have sine of 0 all over 1 plus cosine of 0. So I have 1 times, well, sine of 0 is 0 all over 1 plus cosine of 0 is 1. So this is 1 plus 1. If I had gotten 0 over 0 again, I would have a problem, but I didn't. I got 1 times 0 over 2. So this is 1 times 0, which is 0. So we just proved that the limit as theta goes to 0 of 1 minus cosine theta all over theta is equal to 0. You can put the box. So if you put that square at the bottom and you're trying to prove something, that means that you're done. You did what you set out to do and showed it. So now that we know those couple of limits of trigonometric functions, it will make it easier when we're trying to find limits of trig functions, if we can manipulate them to get into these forms that we know.